Hello students, this is the first series of considering paper 1, Pure Mathematics 1. The code is 9709/11 and I'll be looking at the topic of quadratics. So in this paper we find quadratics. This paper was taken November 2011 and the question of interest in this particular paper we find question 9. So it reads, a line has equation y is equal to kx plus 6, and a curve has equation y is equal to x squared plus 3x plus 2k, where k is a constant. Roman 1, for the case where k is 2, the line and the curve intersect at points A and B. Find the distance AB and the coordinates of the midpoint of AB. 5 marks. 2. Find the two values of k for which the line is a tangent to the curve. 4 marks. So that's the question. Let's look at the solution. Now we are told that y is equal to kx plus 6, the line y, and a curve. Now there's a line, and a curve has equation y is equal to x squared plus 3x plus 2k, where k is a constant. Now, for the case where k is 2, the line and the curve intersect at points A and B. Now, find the distance AB and the coordinates of the midpoint of AB. Now, let's say for k is equal to 2, then we have y will be put to there. It will be 2x plus 6. And this second one will be y is equal to x squared plus 3x plus 4. Because this is 2 plus 4. And we are told that for that particular case, this line intersects this particular curve at 2 points, A and B. So first, it's prudent to first find the two points. Now to find the 2 points, I will equate them because at the point of intersection, they share those points. So by equating, I'll be having x squared plus 3x plus 4 is equal to 2x plus 6. So I'll bring this x this end, it will be a minus. So I have x squared plus x. This 6 will come here, it's a minus, so it's minus 2 is equal to 0. So I have this equation, let's see. It's x squared plus x minus 2 is equal to 0. So I'm looking for two numbers whose product is negative 2. Product is negative 2 and sum is positive 1. Product is negative 2 and sum is positive 1. What are these two values? The two values will be product is negative 2 and sum is, all right, that will be x squared minus x plus 2x minus 2 is equal to 0. So that this here gives me x plus 2x minus x is x, and this minus 2 is just that, yeah. So I factorize and I'll be having x outside So this is x minus 1 plus factorize 2 x minus 1 is equal to 0. That implies that either x plus 2 or x minus 1 is equal to 0. Therefore, x is 1 or negative 2. X is 1 or negative 2. Now, to find the points of intersection, now that I have x is 1 or negative 2, to find the points of intersection, I then substitute these values in either this or this, but I pick the first one. So we say for x is equal to 1, y is, if x is 1, here, if x is 1, so y will be 8. For x is equal to minus 2, y will be, so minus 2, that will be minus 4 plus 6 will be 2, y will be 2. Solve those points as this point here is 0.1, 8, and this point here is point minus 2 and 2. Minus 2 and 2. Yeah, those are the 2 points that I have. Minus 2 and 2. So either of these is point A or B. So I would say this is A. I can assign either A or B. So let me say this is A and this is B. So one point is 1, 8 and the other is minus 2 and 2. So what's the next question? Yeah, find the distance AB. The distance AB will be given by the square root. So let me just say AB. Distance, how do I call it? This may mean vectors, but let me just refer to it as the distance AB. May refer to vectors anyway again. But then what I have is it will be the difference 1 minus minus 2. 1, that is the x coordinate. 1 minus minus 2, which is 1 plus 2. So that becomes 3 squared, plus 8 minus 2, which is 6. So 6 squared, and then we get the root of that. That will give us the distance. Because it's vectors, we are looking at positions on a Cartesian plane where we are defining the x value and the y value. So by finding the difference, the change along the y-axis and the change in the x-axis, that is what gives us the distance. And that's why we subtract as such. So that should give us, this is 9 and this is 36. So that is 9 plus 36, that's 45. So we have it as root of 45. We call it units. Could be kilometers or whichever way we choose to measure it. So it is what, a root of 45. Then the second question is, and the coordinates of the midpoint. Now the midpoint will simply be midpoint will be given by 1 plus minus 2. 1 plus minus 2, which is minus 1. So 1 plus minus 2 divided by 2. That gives us the x coordinate. And then 8 plus 2 divided by 2. 8 plus 2 divided by 2. So this should then give us, this is negative half and 10 and 5. Those are the coordinates at the midpoint. Negative half and 5. Those are the coordinates at the midpoint of AB. Then find the two values for K Find the two values of k for which the line is a tangent to the curve. Find the two values. I want to have this. Find the two values. Find the two values of k for which. Find the two values of k for which the line is a tangent to the curve. Now, we had this and this. The line is a tangent to the curve. So we have kx is kx plus 6 is equal to x squared plus 3x plus 2k. Plus 2k like that. I collect like terms, so I'll be having x squared. I'll be having x squared plus 3x minus kx plus 2k plus 6. Just a minute. X squared plus 3x minus kx plus 2k minus 6. Minus 6. Minus 6. Minus 6. So I can, I see here that I have x squared plus x into 3 minus k plus 2k minus 6. That's the nature of my quadratic. And for that line to be, for that line to be a tangent to the curve, it means that it cuts that curve just at one point. That's when it can be tangential to that curve. So in that case, when it cuts it just once, the condition for that is b squared minus 4ac should give us 0. Should give us 0. But from here, our a from a is 1, our b is 3 minus k, and our c is 2k minus 6. 2k minus 6. A is 1, b is k minus 3, k minus 3, k minus 3. Just a moment before I lose it. If I have kx, okay, so that I see this clearly, let me just put it kx plus x. No big change, I've just shifted the position. So in which case I have x squared plus 3x minus kx plus 2k minus 6 is equal to 0. And then it was x, yes. So I have 3 minus k, 3 minus k, 3 minus k, or k minus 3. It will be x squared minus